So now we're going to come up with equations for velocity in the y direction, displacement in the y direction, and also a Cartesian equation which will tell us how the x displacement changes with the y displacement, so we can look at a graph of the trajectory and can compare it to the no drag scenario. So since we're just going to acknowledge this is in the y direction, so we're just going to rewrite it as ma equals minus mg minus kv, okay? So now we know a is dv dt, so we can say ma, or mdv dt, sorry, equals minus mg minus kv. And I'm just going to multiply it by dt, actually. I guess I'll do that first, just to make it a bit simpler, times minus mg minus kv times dt, so we just multiply both sides by dt. Now if we divide both sides by minus mg minus kv, we get m over minus mg minus kv dv equals dt. Okay, so now we can integrate these, because now we have the v's on the side with the v's, and then there's no t's, so we're fine. So we can do the integral of, so I can take this m outside the integral, and we get 1 over, and then instead of saying minus mg minus kv, if we multiply the top and bottom of the fraction by a minus, this will become mg plus kv, but then we have to bring the minus out the front. Since the minus is a constant, we can bring it out the front of the integral. You get dv equals the integral of dt. And remember, the velocity is going to be from the initial velocity is u to the final velocity v, and time is going to be from the initial 0 to the final t. Okay, so we can't integrate this too easily, so we're going to have to make a substitution like we did last time. So we're going to say, let's say r equals mg plus kv, which means that dr dv equals mg constant's just going to go away, and then it's just going to be equal to k, right? Because so then we can multiply both sides by dv, getting dr equals k dv, which means we can dv is equal to dr divided by k. Okay, so now we can rewrite the integral as minus m times the integral of 1 over, and then mg plus kv is just or, and then we can replace dv with dr divided by k, and since k is a constant, we can take it outside the integral like that, and we can just write dr. Okay, and then the limits of integration are going to be, so we replace the v's with v's, and we get mg plus kv, the same as it was, and then the bottom one's going to be mg plus ku, because we're just replacing the v and the r equation with our limits to find out what they are in terms of or, and then we get equals to the integral, well, the integral of dt is just t, evaluated from 0 to t. So now we're going to get minus m over k multiplied by the integral of 1 over or is just going to be the natural log of the absolute value of or, evaluated from mg plus ku up to mg plus kv, right, equals t minus 0 is just t. So now we can just plug in the values for the integral, so we get minus m over k multiplied by ln of mg plus kv minus ln of mg plus ku, and that's equal to t. We can combine these logs like we did last time. We can just do the division, so it's going to be minus m over k times ln of mg plus kv over mg plus ku, and that's going to be equal to t. So now we want to integrate the velocity again, so we're going to try and get the v by itself, an equation for v. So what we can do is we can multiply both sides by k over m to get rid of this m over k. So we multiply by k over m, so we're going to have ln of mg plus kv over mg plus ku equals, so we multiply by the k and we get kt over then the minus m, we can put the minus there and put the m down there. Now we can do e to the power on both sides, so we get mg plus kv over mg plus ku. These are very bad pluses. It's going to be equal to e to the minus kt over m. So we can multiply both sides by mg plus ku, and we get mg plus kv equals e to the minus kt over m multiplied by mg plus ku. I'm not expanding it out because that'll just make things messier. So now we can just do minus mg on both sides, and we get that kv equals e to the minus kt over m multiplied by mg plus ku minus mg, and then dividing both sides by k, we can just put a divided by k and get rid of this k here. And here is an equation for the velocity in the y direction, except I'm just going to have to change the u here to be a u sine theta, so that it's exactly for the y direction. Okay, and now we can say that Vy is just going to be ds over dt equals all of this, which I'm not bothered to write out again, so I'm going to copy and paste it. Boom. Multiply both sides by dt. So now we can take the integral on both sides, so we get the integral from initial displacement 0 to final is s of ds equals, I'm going to break this into two terms just to make it a bit easier. So we're going to have the integral. Now mg plus ku, these are all constants, so we can pull these to the outside of the integral. They are all constants, multiplied by the integral of from 0 to t of e to the minus kt over m. Yep, dt, sorry. Minus, and now all of these are constants, so we get mg over k times the integral from 0 to t of dt. Okay, so now we're going to have to make a substitution for this second integral, because it's like the reverse chain rule, but there is no chain rule, so we have to do a substitution. I'm going to call it or again, just it doesn't mean the same or as last time, or does it actually? Yeah, I think it actually does. Minus kt over m anyway. It's from the one in the x equation actually. So then we get dr over dt equals minus k over m, which means that dr equals minus k dt over m, which means we can replace dt with m dr over k. Minus m dr over k equals dt. Okay. We're not going to have e to the minus kt over m, we're going to have e to the or. So we can replace this with or, and dt we're going to replace with minus m dr over k. So we can say this is going to be dr. And then remember, the minus m over k is a constant, so we can put that out the front as well. So, okay. And then the limits are going to be different as well. So we're not going to have t, and we're not going to have 0. Instead, we're going to have to plug in t and 0 into this. So we get minus kt over m, and then 0 here, because when you plug 0 into t here, it just or is equal to 0. So now we can finally do this. So we get s equals, I'm just going to expand this out. So we're going to have minus m squared g, and then it's going to be another minus mku all over k squared, multiplied that by the integral of e to the or is just going to be e to the or from minus kt over m to 0, or from 0 to minus kt over m rather, minus, and then the integral of dt is just going to be mg over k, multiplied by the integral of dt is t from t to 0. S equals minus m squared g minus mku over k squared, multiplied by e to the minus kt over m, and then minus e to the 0, which is just minus 1, minus mg over k times t, mg t over k, and then t, when t is 0, that's all just going to be 0. So this is a very messy equation for the displacement in the y direction, and we also, in order to make the displacement for the y direction, have to replace this u with u sine theta, and that is our equation for displacement in the y direction. Now, one last thing I want to do is I want to come up with an equation that relates the displacement in the y direction to the displacement in the x direction, so that we can put it on a graph and see what it looks like, and compare it to the normal graph. So I'm going to go back over to where we did x. So here we got the s of x. So I want to solve for t in one of these equations so we can cancel out the t's by replacing the t with the other equation. This one has a t in the exponent and another t term. So this one's going to be hard to isolate for t. So I'm just going to take the x one and I'm going to isolate for t. So I'm going to start replacing sx with just x because we're just looking at position now. So I'm going to say x, xk to get rid of the k on the bottom, equals minus mu cos theta multiplied by e to the minus kt over m minus 1. So now we divide by minus mu cos theta, we get minus x over xk over mu cos theta. I just put the multiply the top and bottom by minus 1 to put the minus on the top. That's going to be equal to e to the minus kt over m minus 1. We just add 1 to both sides. We get minus xk over mu cos theta equals, sorry, not equals, plus 1 equals e to the minus kt over m. So now we just take the natural log on both sides. So we get ln of minus xk over mu cos theta. That looks like an n. Mu cos theta plus 1. Oh, that's plus 1, and then the end of the absolute value sign equals minus kt over m, which means that t is going to be equal to m over minus m over k multiplied by ln of minus xk over mu cos theta plus 1. Okay, so that's our equation for time. What I'm actually going to do is we're going to keep this one in mind as well. This one's going to be important just to simplify the substitution, I suppose. You'll see why in a second. So I'm just going to bring this. So now we're going to have, the reason I did that, as you can see now, is we have e to the minus kt over m minus 1 here. Actually, I will just show it in green so it stands out. So that this and this are the same, so instead of making a substitution for t in the exponent, which is going to be really complicated, we can just replace this whole thing with minus xk over mu cos theta. Okay, so we get sy, or actually, I'm just going to call it y, because we can do that now, equals minus m squared g minus mku sine theta over k squared multiplied by this bracket we can replace with this, so we get minus x k over mu cos theta minus mg over k, I'm going to write it like this, multiplied by t, and then t is just all of this. So there's a lot of simplification to do, so we get y equals, okay, so the k and the k squared is going to cancel to give us just a k on the denominator. So we're going to get minus x multiplied by minus m squared g minus mku sine theta. Yep, all over just k, because we said the k and the k squared and the k are just going to change to be a k mu cos theta. Okay, so the minus inside the bracket and the minus outside the bracket, it's going to end up being a plus. We're going to have m times m is m squared, then we have g over, and then the k times k is k squared, multiplied by ln of minus xk over mu cos theta plus 1. Okay, we can do some final simplifications here. So we get y equals, we can distribute the x, because you'll see why I did that in a second, and we get minus and a minus makes a plus, x m squared g over, and then we're just going to split the fraction, over k mu cos theta minus, and then minus x times minus x is actually going to be a plus, and we get x mku sine theta over kmu cos theta plus, and then this is just going to be the same, so I'm going to copy it down. Now we get y equals, so now one of the m's are going to cancel, some of the m's, so we're going to get x, and then m squared over m is just m, then g over ku cos theta plus, and then we have x, so a lot's going to cancel here. We have m's are gone, k's are gone, the u's are gone, so we just get x, and then what's sine theta over cos theta? That's just tan theta, plus this horrible term. And that is the equation for y in terms of x. So everything else in here is just a constant, so we can graph this and see what the trajectory looks like, which is what we're going to do in the next part. So now we have an equation for y and x. We have an equation for the displacement of y and the velocity of y up here. Okay, cool.